let's look at a second example of related rates, shall we? So what we have here is the demand equation. We have the price P equals this fraction, 18,000 minus 60x over 400 minus x, where x is the quantity demanded. So, for example, if I wanted to have 100 units demanded, I plug in 100 and I figure out the price point. That's what the demand equation does. You tell me how many units you want your customers to buy. They want to buy 300 units, plug in 300, calculate out the math, and you determine the price it needs to be at. Of course, there's realistic constraints here, as for sure. 300, actually it couldn't be 300, could it? Because if it was 300, that top would be 0. That means you're giving away the product for free. So there is a very careful thing we should note in this problem, that x should be less than 300. Let's think about that just for a moment, okay? That often throws people off of, whoa, why is that true? Well, if you think about it, if x was actually 300, the numerator would be 0. And nobody's going to set the price point at 0 in their company. Not many people are going to give away their product for free. So the number of units we're going to produce that we want demanded is going to be less than 300. So for example, if we want 200, we can plug in 200 and we can set the price point for whatever that is. All right, so now that we have a better handle on the price function, I'd like to look at the following question they've asked. The question is, they say that the daily demand is decreasing at a rate of 20 units per day. The daily demand, well, remember, quantity is X. So the daily demand, the quantity is decreasing. I got to turn my math into symbols, right? Decreasing means negative. So the daily demand is decreasing at 20 units per day. That's how I read that. And that's the symbol for that. At what rate is the price changing? So at what rate is the price changing? So that's what I don't know. At what rate is the price changing? P, dP, dt. Rate is the derivative, by the way. In this case, we're doing a related rate with respect to time. And the particular price unit we're looking at is 30 bucks at price of $30. So again, let's recap one more time. At the price point of 30 bucks, and we know units of demand is shrinking by 20 units per day, what is the price point changing at? At what rate is the price point changing? Good question. Well, if I want to find a rate, I look at my denominator. I hope that's become very clear in related rates. You look at your denominator. Your denominator is with respect to t, which means you take your equation and you got to take your derivative with respect to t. And that means both sides. Well, the derivative on the left side, no big deal. The derivative of p is 1, but by chain rule, is 1 times dp dt. Please see a bunch of my other videos on implicit derivatives and the other related rates to see more examples of this. So again, the derivative of p should be 1 because that's a single variable. But that p, we do not know if it's a function of t, so by the chain rule, we multiply by dp dt. All right, this side, good chance to brush off my quotient rule. Good chance for me to remind you guys how I set up the quotient rule. What I do is I set up my brackets. Please see my previous video on the quotient rule to see how I do it. So I set up my quotient rule. How do I know it's a quotient rule? It is a quotient. It's a fraction. So how do I take the derivative of this? Well, it is u prime v, that is the denominator. The denominator goes into here. I like to place my denominator in place where it's supposed to go right away. So this is the v, as I call it, the denominator, the v function. And so u prime v minus u v prime. So u goes here. The numerator goes here. 18,000 minus 60x goes there. So these, I'm already 3/5 the way done because all these are just the functions plugged in right. The numerator goes here in this bracket. The denominator goes in that bracket and that bracket. And yes, there is a squared. Please recall the quotient rule to figure out how I'm doing this. Now let's take the derivative carefully. U prime, well this is u, so u prime, the derivative of this, well, the derivative of 18,000 is 0. The derivative of negative 60x would be negative 60, but I got to do dx dt because once again, we're taking with respect to t. And I do not know what x is with respect to t, and that's why there's a dx dt. Vice versa, I want to take the derivative of this and put it here. The derivative of 400 is 0. The derivative of a negative x would be a negative 1, but once again, that is an x, not the t that's in the denominator. So we get dx dt. Pretty much, when the letter and the denominator don't match, you're going to have to do the chain rule. That's really the shortcut here. When the bottom letter and the letter in the functions don't match, you're going to need the chain rule, this extra piece. So remember what we're solving for, dp dt, dp dt. Hey, we have dp dt. All I got to do is evaluate this. Let's pause for a moment. What do I need? I need a dx dt. I have it. A negative 20. I need a rate. I need the rate at which units are changing. I have it. Negative 20. I need a particular x. Ooh, this is interesting. I have the price point. I don't have the x. Please notice, I got to pause for a moment. I was about to plug into this, and I realized something right away. I can't just simply plug in. I have to pause for just a second, and I realized they gave me a price point of $30. They didn't give me x. So first, I'm going to read the question, make sure I'm right, and they did. They gave me a price point of $30. They didn't give me x. If they had given me x, I'd plug in x here, x here, x here. I'd plug in for dx dt, and we'd be done. We would just have calculator work to do. Or again, remember, dx dt is negative 20, so I could just shove that into there, and I can also plug that all the way, the negative 20, into here. And you do your order of operations correctly. Once I find x, I can plug it into here, I can plug it into here, and I can plug it into here, and then by calculator, I can get my answer. The rate at which profit is changing per day. Or sorry, that's not profit, that's price. The rate at which price is changing. Got to recall, this is the price function. So the rate at which price is changing is this complicated equation. It's not that complicated if I had numbers to plug in for dx dt, which I do, but I am missing. Please understand that. I had to pause for a moment. I'm taking a moment to pause. It's always good to do that. I have a price point of $30. Well, now we go outside of derivatives and we go back to algebra. I'm going to do a little side work here. Price point is $30. I'm going to put it right there. Price point is $30. I have a 30 equal to this equation. It's time to do good old algebra. I have $30. I'm going to solve for x. I'm going to put 30 over 1. I don't have a lot of board space, so work with me here. Let's go slowly. Put 30 over 1, because that's $30. 30 over 1. Now that it is 30 over 1, say it with me, we are going to, you're right, cross multiply. So 30 times 400 minus x equals 1 times 18,000 minus 60x. Again, the side work here, I need to find x. That's what I'm doing. I'm bringing this down right here. I need to find x. I know the price point, $30, 30 over 1, because that's 30. 30 over 1, cross multiply, and you get this equation. All right, now we have to solve this. No problem. Let's get on down here and get into work. What we have here is 30 times 400, and I don't want to make any mistakes with you guys, so 30 times 400. It's always good to have a TI handy. 12,000. Excellent. 30 times a negative x is negative 30x. Don't forget to distribute. This is algebra time, people, right? This is our algebra moment, what we've been working on all year long. Some good algebra. And that equals 18,000 minus 60x. So now I got to solve for x. No big deal. Add the 60x over there, I get 30x. Please notice, add 60x over here, you get 30x. That means I got to move that over. So subtract 12,000 over, we get 6,000. Because 18,000 minus 12,000 is 6,000. And all I need left to do is divide by 30, and I'll find my x. Divide by 30, and again, just so I don't make any silly mistakes in front of you guys, 6,000 divided by 30, well, it's what I thought it was, 200. So I now have, via algebra, the x value. Now that I have the x value, I'm going to plug that in for x. Wherever you see an x, I'm going to plug it in. I'm going to plug in my dx dt, boom, boom. calculate this all out, and I'll get my dp dt. Just so we all finish this at home together, let's check it out. So what would we do? Let's just kind of write it down here. We're going to have negative 60 times negative 20. So negative 60 times negative 20. Got it. I got that bracket. Times 400 minus x. X is 200, so it's really 200. So that first bracket, when I multiply, is 240,000. So my last little tidbit here, I have 240,000 minus, all right, I got to figure out this piece now. So it is 18,000 minus 60 times x again. X we found was 200. That's 6,000. Times a negative 1 times a negative 20. So times 20, when you do the math correctly, gives me 120,000. Got to be careful with our units here. Could make a simple mistake and don't want to do that. All over the bottom squared. 400 minus 200 is 200, so 200 squared. So I'm looking for this number right here. I'm looking for 240,000 minus 120,000 divided by 200 squared. And I get 3. So there is my final answer. My change in price per day will be $3 increase in price per day. If I want the demand to go down by 20 units per day, I need to increase the price by $3 a day. That makes sense. If you want to decrease demand, what are you going to do? Increase the price. If you increase the price, what are you going to do to the demand? You're going to drop the demand. That's how demand works. So one more time, now that we have everything on the board, we have the demand equation. Got to understand the demand equation. You tell me the quantity you want to sell, I'll tell you the price point to put it at. Excellent. If you tell me the rate at which demand is dropping, 20 units a day, you tell me the price point you're at, 30 bucks. I will determine the price changing. So as the units are dropping 20 per day, the price is increasing $3 a day. That's how they're working against each other. How did I arrive at that? Well, if I want to find a rate, that's the key. If you want to find a rate, the derivative is the way to go. How do I know that's a quotient rule? Come on, guys. It's a fraction. Say it with me. It's a fraction. It's a quotient. So the quotient rule is what I did. If the letter X does not match the bottom letter, which is with respect to, you're going to need to use the chain rule, like I did. Vice versa, the P doesn't match that bottom letter, DT, so once again, I need to use the chain rule. When I plug in, I did notice there was an issue to plug in. I didn't have X right away in the beginning. They were sneaky. I had to pause. This is my pause moment. I was going really fast and I ran into a wall and said, whoa. They gave me the dxdt. That went in nicely. But they didn't give me X. Sneaky. But they did give me a price point. When you give me a price point, I should be able to find the demand. You got it. That's the demand equation. You give me the price point per algebra. I found the demand to be 200 units. Move that down so you guys can see. 200 units. Once I know what X is and dxdt is, I plug it in. I got my fraction here and found $3 per day. Really nice related rate question. All right, guys. Thank you so much for watching this video.